Hey guys, let's get started. Hi, how are you doing? So we are going to get started on lesson number 3. This is actually technically week 4 on your syllabus, but lesson 3, and this is all about heart axis. And what exactly does heart axis mean? That basically means how the heart sits in your chest, and not like this guy here, but you know, my sense of humor. It is what it is. Hopefully, you have printed out your note sheets for today. I have mine printed here. I'm going to walk through some of these so that we understand everything that's going on. But heart axis is what we're going to focus on today, and then some other odds and ends. So let's see. First things first, heart axis is basically just determining how the heart sits in your chest. I'm like this guy? No, not like this guy. It actually it's the angle at which it's sitting. So it can change by different positions you're in, or a medical condition you might have. If you're pregnant, you have a tumor that's pushing against something. So how do we figure this out? So we can actually literally tell like what angle the heart is sitting in the chest based on that apex, the point of the heart. Depending on where that is pointing, is exactly where we're going to figure out what angle on our basically on our angle wheel it's pointing at. Okay, it should technically be pointing towards our left armpit, but at what angle it could be a little bit different for each person, and it can be different in each position, believe it or not. Okay, so I'm actually gonna move my little face a little over here so it's not in the way. All right, next things first. All right, so you should have a wheel. So you should have a picture of a wheel. Mine looks like this. Yes, a picture of a wheel. So that wheel is on your notes, and you need to draw in all those lines. So I have given you 4 pie pieces. So each of those 4 pie pieces, make those into 3 separate ones. So I'm going to go ahead and do that on my paper. You guys can do it with me. I'm going to draw on my paper here. I'm going to make my pizza, my 4 slices into 3 each. So divide your each pie slice into thirds. That is my picture for you up on the screen and the little tiny low below down there. That's what I'm doing. So I'm going to do that with each of my pie pieces. Okay, so here I go. You have time to do that as well. They do not have to be exact, not at all. Okay, this is just 1/3 of each. And you probably have seen this before. It sounds like my printer's going to go off. You have probably seen this before when you're looking at different types of angles. So your finished wheel should look something like this. And it should look like the picture that's on the screen for you. This is to determine heart axis. So the next part is I'm going to start putting the numbers in and then the letters. So I'm going to do the numbers. You can see 0, positive 30, positive 60, positive 90. If you go the other direction, it's negative 30, negative 60. I'm going to start writing those numbers in. Okay. This is the angle at which we're going to look at the different angles for the heart axis. So what these mean is if we determine that the apex is pointing about the angle of the positive 30, then that's going to mean that heart axis is positive 30. Okay, it's the angle we're looking at. So I'm going the other way now for negative 30 and negative 60 and negative 90. Continue all the way around negative 120, negative 150, plus and minus 180, because that's all the way to the other side. And then we had positive 150 and positive 120. So I have written all of my numbers in. So if you need to pause for a moment to get caught up, that's fine. I've written all my numbers in there for you. This is what yours should look like. Okay. I'm going to see if I can make my window a little bit bigger so you can see what I'm doing. I'm going to move it over here, and I wonder if I can make it bigger. I can. Excellent. Trying to make it bigger so you can follow along a little bit easier. And I'll go up here. All right, so there's my thing. All right, so this is what it should look like. So my wheel looks a lot like the wheel on the screen, right? So now I need to add in the AVL, the AVR, and notice that AVR has a negative in front of it. I do need you to put the negative in there. Okay, so we're going to put the negative in there. So let me do that, and then I'll show you what mine looks like. I'm going to use a different color just because I like to switch it up a little bit. Oh, that one you can't see real well, so let me try another color. Make sure you put the negative in front of the AVR, and I'll explain why in a moment. All right, this is what my wheel looks like now, and yours should look very similar. So I've gotten all of those written in there. All my numbers are there for the wheel, and then my letters I've added in. Notice that those letters, the 6 of them, the AVL, the 1, the negative AVR, the 2, the AVF, and the 3, all coincide with leads on our EKG. Okay, so 6 of the 12 leads, it coincides with those 6. So we're going to be using those 6 to determine what the heart axis is in the heart. Simple, right? So the next part we're going to do is, what do all of these mean? So there are different ranges for what's normal and what isn't normal, kind of outside the norm. So let's click on this and see what's next. So our first one is normal axis. So the normal axis, if you determine the heart axis is somewhere between negative 30 all the way to positive 90 on the wheel, that's somewhere normal, meaning the apex, if it's pointing in that direction between negative 30 and positive 90 in the wheel, if we put that wheel on our heart, basically I put my wheel right on my heart, okay? If it's pointing in that direction, then it's normal, all right? So how do we depict that? I'm going to do it kind of like use colors. You can use colors if you want. If you don't have colors, just shade it in however works for you. I'm making my green, and I'm going to put normal axis. And then I'm probably going to put negative 30 to positive 90. Make sure you're using the positive and 90 negative so you don't get mixed up. All right, this is what I wrote for mine. I did normal axis like this, negative 30 to positive 90. So any axis I determine is somewhere between negative 30 and positive 90. That is a normal axis. Your apex can fluctuate between those two, anywhere between negative 30 to positive 90, and still be considered normal. And what would change our heart axis from being like moving in different directions is sometimes just going from sitting to standing or laying down to sitting. When we're sitting, stuff's kind of squished a little bit, so stuff does end up being squished up a little bit. If you think of a pregnant woman, everything's squished in there, so it squishes the heart up, so the heart axis is a little bit higher than normal people. Once we stand, though, stuff falls down, right? So the heart axis might be pointing down, so the apex might actually point down more, and it could be closer to 90 degrees when we're standing up in different positions. When I do stress tests, we do EKGs, resting EKGs, in a couple different positions so that we can see the difference in the axis. So I do one typically standing, sitting first, and then standing. We used to do one lying down first, then sitting, then standing. But sitting and standing we found out was probably enough. Just as long as we had the two different axes, we're good. Then, of course, when we lay down, stuff spreads out. So there's lots of space for it to spread out and kind of move to the side. So in the next axis, next range of axis is going to be the right axis deviation. Okay, so if it's a little bit further to the right, and again, this is the heart, this is the patient's right, correct? Since this is our left, this is our right, patient's right. So if it's over in this way between positive 90 up to 180, it's going to be considered a right axis deviation. Not too big of a deal. It does happen often. I see this often, and it's not really that big a deal. It's just kind of squished over to the right a little bit. No big deal. So let's color that one in. I'm going to use my pink, I think, for this one. If you can just kind of, I'm using 3 different colors. You do not have to shade it however you think works best for you. And this is going to be called the right axis deviation. And that is positive 90 to plus or minus 180. So this is what my wheel looks like now. This is for your notes. Again, I use pretty colors. You do not have to. If you don't have them, it's okay. But just know that you can shade it in different ways, highlight it, whatever you want to do for the normal axis and the right axis deviation. Of course, you can pause this at any time if I'm going too fast or if you can't quite keep up. No big deal. Pause it if you need to. Next one is the left axis deviation, and this is going to be up here at the top. So anywhere from negative 30 up to negative 90 would be considered left axis deviation. I see this a lot again in pregnant women because stuff gets squished. and it's squishing that hard axis up a little bit. Very normal for someone who's pregnant. So, you just have to know your patients real well and work with it that way. All right, I'm going to do this different color here. This one's going to be my left axis. Left axis deviation, -30 to -90. Okay, so here we are again. Here's what it looks like. And I use pretty colors. It's up to you to use if you want to use colors, it's up to you. We got one more piece of the pie left. And it's way over on the other side. This would be called extreme axis deviation. Now think about that for a minute. Think about if your heart axis was up here. So that means your apex is up here. Your heart would literally be upside down. Not normal, right? It's not like your heart wakes up one morning. It's like, hey, I think I want to be upside down today. That's not how that works. So it's typically something they're born with, or it happened in some sort of trauma incident where things got moved around inside. And if we have an extreme axis deviation, they would usually have to fix it some sort of surgical way. Okay, so this is anywhere between -90 to the ±180. And again, this is extreme actions or situations that we don't see very often. So I'm going to color that last one in. This is my extreme. Extreme axis deviation. And it is -90 to ±180. So as long as your wheel looks something like this is what's going to help us determine our hard axis, okay? And we'll only need to use this while we're learning it, and then after this, probably won't need to use it too much, okay? As long as you start memorizing the parts, it's pretty easy to memorize, and I'm going to go through that with you as well, okay? All right, pause if you need to, but that's what your wheel should look like. Moving on to the next page, which is we're going to use this practice right here. So number one in your practice packet, we're going to practice. So what we're going to do with number one is we're going to look for, I'm actually going to skip ahead to number one. I know I'm skipping it. I'll come back. Okay, skip ahead to number one. I'm going to move me over here because I don't need to be down there. Okay, so on number one, again, we're looking at leads 1, 2, and 3, AVR, AVL, and AVF, correct? Those are our 6. So we're going to look at the size of the QRS in each of these leads. And we're looking for the QRS that is probably the tallest, okay? Sometimes it's very obvious. They stand out like a sore thumb. Sometimes not so obvious. This one's pretty easy, I think, to determine, okay? So we're looking at lead 1, lead 2, and lead 3. We've already learned Ian Thoven's triangle. Let's look at Ian Thoven's triangle for this one. If I stack 1 on top of 3, it should equal the size of 2. And again, we're just eyeballing it, right? So stack this on top of this, it's a yes. Pretty close, right? Ian Thoven's triangle is correct. We're still going to look at the size of these 3 and these 3. This one to me looks like it's the tallest. Lead 2. And what is in anything in the world, what's the opposite of the tallest is the smallest, right? So we're going to actually check our work. We're going to do the opposite of the tallest, which should be the smallest, okay? And what does opposite mean when we're talking about the wheel? It means 90 degrees away, all right? So you should have your wheel in front of you, all right? Wheel in front of you. So I'm going to attempt to use my document camera. It's been freezing up on me. So I want to try it and see if I can get it to work. If it works for 1 minute or so and I can still point to it, then we're good. If it freezes, I'm not going to try again. Okay, it's been freezing up on me and I haven't been able to use it. We'll give it a shot. So we're looking at lead 2, which on the wheel is positive 60. Okay, on the wheel is positive 60. I'll just go back. I'll go back a slide. Give me 1 second. Okay, so let's say positive 60, okay, is the tallest, lead 2, which we think it is in this practice EKG number 1. Lead 2 does look like it's the tallest QRS, correct? So the opposite of 60, or lead 2, 90 degrees away, is AVL. So if I look on my wheel right here, 60 over here, AVL. So 2 and AVL are opposites. Okay. So on my EKG, and again, I'm going to flip forward, on my EKG, 2 and AVL are opposites. So if this one's the tallest, then AVL should be the smallest. And by golly, it does check out, correct? This is definitely a very small QRS. Of the 6, it is the smallest. Does that make sense? I'll say it one more time. So I'll go back and show you the wheel. We determined first that of these 6 leads, lead 2 was the tallest QRS. It had the tallest QRS, biggest one. So it's opposite by what we see on the wheel here. If I go 60 and I go 90 degrees away, gives me AVL. So now I need to check, is AVL the smallest? Is AVL the smallest? By golly, it is. So yes, our heart axis is in lead 2, which is equal to 60, according to the wheel. Lead 2 is 60, positive 60 degrees. So our heart axis for number 1 is positive 60. So I'm going to write that right on my EKG, right at the top. Plus 60 is my axis. So on the top of mine, I wrote positive 60 is my axis in my notes. Okay. We determined also that Ian's over triangle was correct, so I can put E triangle equals yes. And then the heart rate, we can determine another time. I'm not concerned about the heart rate. We're doing axis in Ian's over triangle right now. Okay. So that's what your correct answer is for number 1. Axis is positive 60, and Ian's over triangle is yes. All right, so for fun, let's figure out what our opposites are. Okay, so I'm going to go back a few to this one right here. And again, I need to move my little face. So opposites on here, if I start with 1, that's our very top one at the top, right? And you can do this on your practice EKG. This is what I would suggest you do, okay? So lead 1, 90 degrees away from lead 1 is AVF. So I'm going to do circle 1 and AVF. I'm going to try and use a bright color here. 1 and AVF are opposites. So I did this. 1 and AVF are always going to be opposites. So circle the 1, circle the AVF, and make them opposites. This is just like a little cheat sheet for you to keep on hand. Okay? And then when we did lead 2, we already know this one. Lead 2 is opposite 90 degrees away is AVL. So that's right next to it. So 2 and AVL are always opposites. So that's what it should look like next. 2 and AVL are opposites because they're 90 degrees away on the wheel. Okay? And then 3, 90 degrees away from 3 is AVR. Okay? So circle 3 and AVR and make those opposites. Those two are opposites. So they always are opposites. So 1 is always an opposite with AVF. 2 is always an opposite with AVL. And 3 is always an opposite with AVR. And what I didn't mention was the AVR thing. So notice how AVR has a negative next to it. A negative means that the QRS in AVR is supposed to be negative. That means that's one of the reasons we know it's normal. So whenever we do an EKG and perform it and we look at AVR, the QRS and AVR should be in negative deflection. Okay. If it's not, something might be a little bit awry. Definitely their heart axis is messed up, or perhaps we have some lead wires in the wrong places. Okay, so that's one indication you can tell if it's in the wrong place. All right, so those are always opposites. The 1 in AVF, the 2 in AVL, and the 3 in AVR. Okay? And I'm going to use a different color here. So the next thing we need to do is we need to put down the leads and what they represent, what angle they represent, so that we can memorize that in our head, okay? And visualize it. So lead 1, as you can see by the wheel, is 0. So I'm going to put a 0 right by lead 1, 0 degrees. Lead 2 is 60 plus 60 degrees, and lead 3 is positive 120 degrees. So it makes a pattern. It goes 0, 60, 120. And then AVR, our negative AVR, is positive 30 degrees. Then we have negative 30 degrees for AVL, and for AVF, we have positive 90 degrees. So here's your cheats for how your hard axis goes. I'm going to try to get that in as close as I can. So write this on your paper. 1 and AVF go together, 2 and AVL go together, 3 and AVR go together, and then write down the axis. 0, 60, 120, positive 30, negative 30, and positive 90. So now when we go and we look at the hard axis, and if we visualize that and memorize that little cheat sheet chart, we won't even have to use the wheel. Okay? I used the wheel to help you understand how we got to those numbers, just so you understand a little bit better. All right, so let's try doing a couple more EKGs then. Let's get on to EKG number 2. I'm going through. All right, EKG number 2, and I gotta move my face. We're just using the leads 1, 2, 3, AVR, AVL, and AVF. So looking at these 3, go ahead and determine Einthoven's triangle first. It does 1 plus 3 equal 2. This looks pretty straightforward. For me, I'm going to say E triangle is a yes. And then the heart axis itself is I'm going to do a little backwards this time. Instead of trying to find the tallest, I'm going to try and find the smallest and take its opposite. Okay? Smallest and take the opposite. Hopefully that makes sense to you. So if I do the smallest of these 6, which to me is definitely AVL, super small, right? What's the opposite of AVL? Right next to it, it's 2, correct? So if this is the tallest, this is the smallest, this should be the tallest. Now we're looking around, it does look like the tallest to me. So this would be 60. So my heart axis equals 60 degrees. Make sure you put the positive in front of it. Remember that we had 0, 60, 120, positive 30, negative 30, and 90. Remember that cheat sheet there? And if you look at this EKG, notice that the AVL is the smallest, so I take the opposite, which is 2, and that's positive 60. So this hard axis is positive 60 for number 2. We got one more to do, number 3. Pause if you need to. Here's number 3. Take a look at those. Take a look at Einthoven's triangle. For 3. Okay, Einthoven's triangle is 1 plus 3 equals 2. And in this situation, 1, since 3 is a little bit negative, we subtract it, correct? And this should be a yes, because this should be a little smaller than this one because we are subtracting because it's negative. So E triangle is a yes for this one. And then we're looking at heart axis. So we've got a couple of different things going on here. Again, you can always look for the tallest one, right? And again, sometimes you might find the ones that they don't look tall, or there's a couple that look the same size, so it's hard to tell. So for me, I like this one as the tallest one, and its opposite is here. So I need to double check and see if AVF is actually the smallest. It's pretty small, but 3 looks small too. They both look small. In fact, I think sometimes 3 looks smaller. And 3's opposite is AVR. So I can argue about this one's a little bit bigger than this one as much as I want and everything. I think it's somewhere between the 2. So how do we figure that out, right? Now, if you said the heart axis was 0 because you think 1 is the tallest, I would not count it wrong. It would be okay. All right. And then if you said that AVR was the tallest, so positive 30 was the heart axis, I would not count that wrong either. That is a correct answer also. If we want to get really, really specific, and we can't decide which one is the smallest or which one is the tallest, we would take halfway between the two. So this one being the tallest would be 0, and this one being the tallest would be positive 30, because these are both small, and those are the opposites. Halfway between 0 and 30 is 15. So I would almost count this as hard axis being 15 degrees. Again, if you put 0, 15, or 30, you would be correct. It's a guesstimate, okay? All of those axis angles fit in the normal range. That's all we really care about, is that it fits into the normal range. So I'm actually going to put axis equals 15 degrees, just because I like to be fancy like that. Make sure you put the positive, okay? And again, that's because I thought that this one and this one both look about the same size. So I took the small one. So I took their opposites, 1 and AVR, as my tallest, and this one's 0 and this one's 30, and I took halfway between, which made 15. If you didn't get it the second time, just rewind this and watch it over again, and watch me go through each step a couple different times until you get it, okay? It seems more complicated than it actually is. All right. Hopefully you got that. Next, what I would do is I would pause here and I would go into your practice packet that we've been working on in class, and go ahead and try to determine the heart axis for each one in the packet. Okay. Looking at my packet here, I'm going to go ahead and try to do the heart axis for this number 1 that we have. And if you don't want to know the answer right away, pause and try to figure it out yourself. But looking at number 1, hopefully you have your packet in front of you. I'm going to look at it as well. Looking at number 1, it looks like AVL is the smallest. Again, I like to go to the smallest first, because taking the opposite to going the largest is the easier. Sometimes it's easier to find the smallest. Taking its opposite would be lead number 2, which is positive 60 for the hard axis. So I would say this hard axis is positive 60 for number 1. Okay, again, how did I find that? Looking at my EKG, I don't have it up on the screen for you. I just have my packet. Okay, so hopefully you have your packet in front of you. And looking at AVL on the packet, number 1 EKG, it looks like AVL is the smallest of the 6, that QRS. That doesn't mean that AVL is the hard axis. It means the opposite is the hard axis, because the tallest is the hard axis. So lead number 2 would be its opposite. It does look like it's the tallest. So that makes it positive 60, because we go 0, 60, 120, positive 30, negative 30, 90. I'm just going to do a couple of these with you, and then you can finish them up on your own. So EKG number 2, heart axis for this one, very similar to EKG number 1. Look for the smallest one first. See if you got it. Got the smallest one first. Excellent. Smallest one is AVL to me. Take its opposite, which is lead 2. Again, we have a positive 60 heart axis, because lead 2 is positive 60. Remember, it goes 0, 60, 120, positive 30, negative 30, 90. And the heart axis is always the tallest. We confirm it by taking its opposite, which is the smallest. Okay, hopefully you're getting this. Number 3. If I look at number 3, I'm looking for this. I go for the smallest. It's way easier to determine if I go for the smallest and take the opposite. So I'll pause for a minute. You try to find the smallest between 1, 2, 3, AVR, AVL, and AVF. Looks like I need to pause for a moment.